The second step in our ideal redesign methodology is to analyze problems in the current system and also problems in the current future of the system. As a theoretical background to problem analysis, we will deal again with emergence, co-production, impact, and current futures. We have discussed those in more detail in the previous module. Another characteristic of systemic problems is that they are multidimensional. They reflect all dimensions. Normally, different stakeholders are associated with different dimensions. For example, the financier of a project is associated with the economic dimension. The educationist may be associated with the cultural dimension, and a government department typically reflects the political dimension. However, each stakeholder can also display all dimensions. If you're looking at the parents in the context of an education system, their financial decision of which school to choose could be influenced by cultural considerations like language or religion, economic, like how much money is available in the family, by political dimensions, for example, an ideological preference, ecological dimensions like the proximity of a school geographically, the psychological dimension, maybe the child has particular likes or dislikes or specific education needs, and physiological dimension, the health considerations, for example. In other words, problems can be co-produced by different stakeholders reflecting different dimensions. They can also be co-produced by one stakeholder in different dimensions. Besides being multidimensional, systems also span levels in the containing systems hierarchy. In Module 1, we learned that a system is co-produced by cofactors arising in the outer environment, inner environment, and the system itself. Likewise, a systemic problem is co-produced by cofactors from the outer environment, inner environment, and itself. For example, if we look at the education problem again, it will be co-produced by the outer environment, maybe economic constraints in society, or a political religious conflict or natural disasters. It will be co-produced from the inner environment by the learners themselves, who may not be motivated, or they may be diseased, traumatized if we are in a region of conflict. And then there will be problems arising from the system itself. It may be badly administered, it may have out-of-date procedures, there may be corruption in the system, and so on. Thus, systemic problems always span three levels: the outer, inner, and the level of the self. What is also interesting about the nature of systemic problems is that very often the solutions in one system can co-create problems in another system. A typical example is the educated youth unemployment issue. One of the problems of education systems is school dropout rates, and that maybe not enough pupils continue with university education. So education systems try to improve the situation by getting more pupils to matriculation levels and more matriculants into universities and to complete universities. At the same time, the amount of jobs available for educated youth are not growing at the same rate. So the more successful the solution in education is, in other words, the more pupils are reaching higher levels of education, the bigger the educated youth unemployment becomes. Another source of systemic problems is optimization. In Module 1, we learned that if we optimize a part, we can sub-optimize the whole. And we gave the example that if we either overshoot on the side of customization or standardization, the organization as a whole will suffer. And that we need to optimize the system at the level of the organization and create a balance between its different functions, the marketing and the operations function, for example, in order to avoid problems for the organization. Another example would be teamwork. If the members of the team focus on their own perspective and on their own expertise, it is likely that the team output is suboptimal. While if the experts contribute in the interest of the overarching topic with which the teamwork is concerned with, then it is likely that the team output will be optimal. What we need to bear in mind as we do a problem analysis is that the logic of the problem is not the logic of the solution. We are not doing a problem analysis in order to find solutions. That's very important. Even if we find occasionally a problem that can be solved, we list it also. We list all problems that we can identify, those we can solve and those we cannot solve but need to dissolve. Our orientation should be to identify as many problem cofactors and problems as we can. So the first exercise we are doing is to identify the problems in the current system. And you are asked to identify your biggest problems. And we suggest you look especially for boiling frogs. Those are those problems that are gradually getting worse. You don't maybe even notice that they're getting worse. An example could be a declining enthusiasm for what you're doing. This is a very subtle frog and you may miss it. So be aware to look for the biggest problems you could think of. The second exercise will ask you to identify the problem cofactors. So for each of those problems you have listed, you are now asked to identify the cofactors to each of those problems. And the exercise asks you first to do a free flow, so list any cofactor you can think of, and when you're thinking you're finished with the list and you have dealt with all problems and their cofactors, we suggest that you use multidimensionality and look if you can add to any one of those original problems some more cofactors. So you would look, could I add some psychological cofactors, like lack of enthusiasm, or some cultural, ethical, aesthetic, knowledge-related, economic, political, technological, or maybe some ecological, physiological, biological, physical cofactors. Depends what you deal with. Physical, biological, and so on would be relevant, for example, in situations of if you're dealing with maintenance or healthcare or something like that. It may not always be of relevance in each problem context. You have now identified problems and the problem cofactors. So we would like you to determine which of those problems and cofactors need solving and which need dissolving. We have explained the difference between the two of them. In praxis, however, it may not always be easy to distinguish, and we leave it to you if you want to solve or need to dissolve the issue. So the exercise involved is marking each problem and cofactor accordingly. We would also like you to do an exercise where you identify past failures and the cofactors of these failures. This can be a very important exercise to learn from your past failures and to use those failures as improvement. We all should be using past experience to learn from. So this is what we want to do here. So first of all, identify one or two of the biggest failures associated with your case study. If you recently joined an organization, you can also look at it from past work life. If you have only recently started to work, then look for the failures in a school project, for argument's sake. And then identify the factors that co-produced each failure and treat them as the previous exercise. Your failure would be like a problem and the cofactors would be treated like cofactors. The next exercise we want to do is to draw a systems dynamics model. So what we want you to do is you take your problems and a selection of cofactors, put them on a piece of paper and draw a systems dynamics model with it. In other words, draw the impacts between them. So the error means this problem impacts on another problem. So for example, if one of my problems is growing workload, and another one is lack of enthusiasm for work, and I'm looking at, does my growing workload impact on my lack of enthusiasm? If the answer is yes, which I'm sure it would be, then you're drawing an error from the growing workload to the lack of enthusiasm. And once you have drawn the various errors, you get a good idea of what your work situation is like, what the dynamics of your work situation is like. You will find that those modules that have a lot of errors going out are the so-called active variables. So you would need to focus later on in the design, especially on those variables, because if you change something there, it will have an impact on a lot of the other variables. Those variables that have a lot of errors moving into it, they are the so-called passive variables. They're affected by other things. So you will not necessarily change that particular variable, but you will have to change those that give rise to the passive variable. It is also useful to include some external variables. What we mean here is, if you read through a list of cofactors of the previous exercise, you will find that some of the reasons why you have one of those problems you listed at the beginning is because other stakeholders in the environment, other departments, maybe the organization as a whole, or even from outside the organization, have an impact or are a cofactor why you have a problem. So it is useful to include a few external variables. Variables is another word for cofactor here, or problem that we are putting into our systems dynamics model. So include a few external ones so that you get a feel how your function is interrelated with a larger whole and how that impacts on you. Because later on in the design we will need to also change how we are interacting with our environment. So we will have to come up with some problem dissolving ideas around that as well. We would also like you to do a trend analysis. And what we mean here is identify important quantitative trends associated with your case study that indicate a deteriorating problem or boiling frog, and project them forward. So for example, if you're 5 years in your organization, what was the cost situation and how has it changed? Or the budgets, or if you're in marketing, what changed in the market share or in the amount of sales? Did they decline? Did they increase? Identify sort of key quantitative data that could make a description or could give you an indication how your work situation has changed in the course of the last few years, and then project them forward into the future in the next 5 to 10 years. In forecasting, we sort of have a rule of thumb that says you can only forecast as much forward as you have data in the history. So don't take the change of last year to this year and project it 20 years forward into the future. This is not necessarily a valid forecasting technique. And also we would like you to look for data pertaining to your function. So if you're in marketing, then take that area you are responsible for and not necessarily the marketing situation of the organization as a whole or the whole marketing department. We would also like you to do a qualitative forecast. So take one of your boiling frogs and describe how it has changed over the last 5 years, how it has become gradually worse, and how it would change over the next few years if the current momentum carries on as it does now. So both quantitative and qualitative trends, if they're getting worse, can be boiling frogs. But we want you to describe the one quantitatively and another qualitatively. And then the last exercise is to explore current future scenarios. A scenario is really a story of how a situation unfolds into the future. And we would like you to do current future scenarios.
Consider all problems and cofactors. How could your case study develop over the next 5 to 10 years?
To identify 2 stories. The one is what is the best case scenario, and the other, what is the worst case scenario. So if I'm, for example, wanting to look about my health in the next 5 years, and I'm looking at my nutrition, my exercise life, my stress management, and a few of other critical variables, then what is the best case that my future could look like in terms of health 5 or 10 years from now, and what's the worst case? And to make a story like that, we need what we call a scenario logic. What is the underlying logic that things are getting so much worse, or that things get relatively less worse, or even stay the same, or even get better, although the current future rarely gets better unless we already have ideals and we are already moving towards an ideal. Now let us give some tips for problem analysis. The most important tip is, do not use keywords to describe a problem or a problem cofactor, but use a sentence or a part sentence. For example, communication problem. I have communication problems in my work is not a problem. This is a keyword. We don't know what it is. Is there too much communication? Are you overburdened with too much? Or don't you have the kind of communication that you need? Or is communication withheld from maybe your boss, or what? So you need to be specific what the communication issue is. And the rule here is, anybody reading what you wrote must be able to understand what the issue is. So you have to be clear and specific. And I cannot emphasize that enough, especially in teamwork. You go and say, don't do keywords, do sentences, and people still come back with keywords. And we have to throw those things out as output because they are meaningless. So we cannot emphasize that enough.
The more effort you put into the problem analysis, the better foundation you create for a creative ideal design and also for future improvements to your case study system.
Let us now summarize the problem steps again and relate them to the different theoretical concepts. First, you were asked to identify problems in the current system. Those problems are typically an emergence from various cofactors that you were asked in the second step. So identification of problem cofactors has to do with the fact that everything in the universe is co-produced. Then you were asked to distinguish between problem solving and dissolving, and this has to do with the distinction between problem solving, which is restoring the system to the current future, and problem dissolving, which implies creating a new, transformed future for the system. Then we asked you to identify some past failures. Those failures again were an emergence from different cofactors, which you also were asked to identify, and that relates to co-production. Then you were asked to draw a systems dynamics model to determine the impact between the problems and problem cofactors and to get a sense of the dynamics of your situation. Then you identified trends and extrapolated them into the current future, and also to explore current future scenarios. So again, this has to do with the current future and how it could possibly unfold in the worst case or the best case. What is the importance of problem analysis in general? First of all, the problem analysis gives you an indication about the nature and the magnitude of your situation and the change that will be required. Are there lots of things wrong? Is there qualitatively something wrong? Or are there just a few niggly little problems that you can fix and your situation will be better in future? So it gives you a very good indication of that. Are you a problem-riddled system that needs to be redesigned? Or are you a well-functioning system that needs to be optimized? So in other words, a few minor things being changed and a few isolated problems being solved. Very important is that the more problems and problem cofactors you identify, the greater is the potential for improvement. Really, one cannot improve a perfect system. There's nothing as boring as perfection. If you have no problems in your life, how will you want to develop? It's the challenge of not knowing where to start. However, if you are listing a lot of problems, then suddenly you have an idea, oh, this needs to change, that needs to change, and suddenly change development becomes easy. One is motivated to change. Now that you have analyzed your problem situation from various angles, it can be useful to integrate your situation and express it using rational or non-rational methodologies, such as drawing, storytelling, symbols, analogies, or if you're brave, even dancing and music. The exercise we would suggest that you do is draw the current situation, so make a picture of it, or give a symbol that expresses the current situation. Not a specific problem, but the whole current situation of your work life and the problems in it. The method uses the creativity of your subconscious mind and also the pattern recognition ability of your subconscious mind. So it is quite possible that there's a deeper underlying cause of your work situation that suddenly is coming to the fore as a result of this exercise. It very often expresses very beautifully in one picture what you have been analyzing now for quite a few hours, and have fun doing it.